We saw that when alpha is an acute angle, then the tangent of alpha is equal to the sine of alpha over the cosine of alpha, and the cotangent of alpha is equal to the cosine of alpha over the sine of alpha. And this is how the tangent and the cotangent are defined for other angles, just the denominator must not be equal to 0. Can tangent be represented on the unit circle? Let's draw a vertical line through this point. Now the line OM intersects our vertical line at a point that we shall call M'. The coordinates of point M are the cosine of alpha and the sine of alpha. While the coordinates of M' are 1. So 1 is the x-coordinate, and the y-coordinate we don't know yet, so we'll just write ym'. Now M and M' are on the same line as the origin O, and that means that their coordinates are proportional. In other words, the coordinates of point M' are equal to some number k times the coordinates of point M. But that means that the x-coordinate of M', which is equal to 1, is also equal to k times the cosine of alpha. And this gives us that k is equal to 1 over the cosine of alpha. And ym' is equal to k times the sine of alpha. And this is now equal to 1 over the cosine of alpha times the sine of alpha, which is equal to the sine of alpha over the cosine of alpha, and that is equal to the tangent of alpha. So the y-coordinate of M' is the tangent of alpha. Is alpha the only angle for which the intersection is at M'? Well, no. For instance, for alpha plus 180 degrees, the intersection is also at M'. Does that mean that the tangent of alpha plus 180 degrees is equal to the tangent of alpha? Yes, because the tangent of alpha plus 180 degrees is equal to the sine of alpha plus 180 degrees over the cosine of alpha plus 180 degrees. But the sine of alpha plus 180 degrees is equal to minus the sine of alpha, and the cosine of alpha plus 180 degrees is equal to minus the cosine of alpha. And this is equal to the sine of alpha over the cosine of alpha, which is the tangent of alpha. In this case, M' is above the x-axis, which means that the tangent of alpha is positive. In cases when m' is below the x-axis, the tangent is negative, and for this particular alpha, that is because the sine of alpha is greater than 0, while the cosine of alpha is less than 0. We started by recalling that for an acute angle alpha, the tangent of alpha is equal to the sine of alpha over the cosine of alpha, and the cotangent of alpha is equal to the cosine of alpha over the sine of alpha. We use that as our definition of the tangent and the cotangent of any angle, provided that the denominator isn't 0. Then we drew a vertical line so that it intersects the x-axis at x is equal to 1. Intersection of that line and line OM we denoted as m'. The x-coordinate of m' was 1, while the y-coordinate was unknown. We then noted that m and m' lay on the same line as the origin O, which meant that their coordinates were proportional. From there we calculated that the y-coordinate of m' is the tangent of alpha. This means that when m' is above the x-axis, the tangent of alpha is positive, and when m' is below the x-axis, the tangent of alpha is negative. That is the way we visually represented the tangent of an angle. With that in mind, I leave you with this question. How can the cotangent of alpha be visually represented? That is all for this video. If you liked it, click the like button, it helps with the YouTube algorithm. And I'll see you next time.